Hi guys, today we're going to talk about compound interest, which is interest earned on top of your interest. It's a better option if you were ever at a bank and they asked you, would you rather have your interest just earned at the same rate over the years, or would you rather have your interest compounded? You always typically pick compounded, I would think. I'm not a pro investor, but compounded interest just earns you interest off more money over time. So let's look at the formula first, okay? And if you want to print out this template, this exact template of the follow-up questions and the notes are on WITS if you prefer not to write it. If you are going to write everything, just hit pause and copy down what you see and then press play and we'll be on the same page, okay? So these are the notes. The first thing we're going to talk about is the formula. It looks very similar to yesterday's or Monday's formula, but with one little difference. And if you are looking at your actual notes that we gave you guys for Unit 9, this is page 17, day 5, compounded interest. So the formula for this is going to be T equals, same as yesterday, Monday, sorry, I recorded it yesterday, but it is Monday. T equals P parentheses 1. In this case, compounded interest usually just increases, okay? You don't usually see a decrease in this situation. You have your rate still, but you actually are dividing it by your n, which we'll talk about in a second. And then you're raising it to the t power again, but you're also multiplying that by the same number n here. N is going to be the same number both times, okay? So let's talk about what n is, since that's our big difference in formula. Everything else was the same from Monday, except for the n's. So terms to know. These are the terms that are going to indicate your n's, okay? And they're these words right here. And they discuss how often your interest would be compounded, okay? That's the big difference here. If you see the word compounded, you're going to use this formula right here. The only time the formulas are the same is if it's compounded annually, because annually means one time a year. And if I put a 1 here, my R is going to be the same. And if I multiply my T by 1, it's going to stay the same. So you could actually use either formula if it's compounded annually. Semi-annually, your N, I should be saying N equals 2. Quarterly, your N is going to equal 4. There's 4 quarters in a year. Monthly, hopefully you all know this, 12 months in a year, so N would equal 12. Weekly, this might be one you don't know, but 52 weeks in a year, even though they all seem to blend together now. Bi-weekly would mean every 2 weeks, so that you cut the weeks in half, 26. And then daily, hopefully you know this one too, N equals 365, as long as there's not a leap year. But we're going to stick with that, okay? The most common ones to look out for that you're going to see, especially today, are quarterly and monthly. Those are the ones you really want to make sure you know. You will see annually. Again, annually doesn't change the formula from Monday's formula to this one because one doesn't really affect anything here. So just so you're aware. And then let's just talk about what these letters mean again. So T, the capital T is your total amount. Your P, it's called the principal. It's also your beginning amount. Okay, so I like to use the beginning amount, but let's just principal. We'll put this down so that you guys can see that vocab. And in parentheses, it's your beginning amount. Your R is still your rate, written as a decimal. Your T is still the time. And now your N is the number of times interest is compounded. So number of times interest is compounded. Okay, so N is what we're highlighting in yellow here. You're going to find it here and here. It's going to be the same number both times. If it says compounded quarterly, you're putting a 4 in for N. Monthly, you're putting in 12, okay? So that's the only really new thing in today's lesson. So hopefully it'll go well. So here are your 2 word problems. If you haven't written these down and you're writing down on a separate sheet of paper, please hit pause and make sure you get those down now, okay? That says 6,500. Sorry about my bad writing there. All right, if you have this printed out, out from the template I provided on WITS under the document section, then you can just follow with me here. So Maria's parents have invested $14,000 at 6% per year compounded. So right now, I see the word compounded, which triggers me to use this formula right here, okay? If you don't see the word compounded, you would use Monday's formula. So compounded monthly. So that means, I'll write this in red, my notes, N equals 12, right? There's 12 months in a year. So I'm gonna list them out again. I'm gonna list out the P, the R, your T, and your N. So N is gonna be 12. How much money will be in the account after 10 years? Sorry, I skipped over a lot of information here. So $14,000 is what was invested. So that's gonna be my beginning amount, my P. At a rate of 6%, that's gonna be my rate. Written as a decimal would be 0.06. Remember, you take the 6, move the decimal left twice, it's 0.06. And then the time, in this case, they gave us 2, so we're gonna have to plug this in twice. The time is gonna first be 10 years, then it's gonna be 20, okay? So leave room so that you can plug this in twice. So when I see the word compounded, I use this formula above here. T equals P parentheses 1 plus your rate divided your N divided by N times your T, raised to the T times N. Don't listen to me, just write what I'm writing, I guess. All right, so let's plug everything in. T equals 14,000 parentheses 1 plus the rate of 0.06 divided by N, which is 12, all raised to the time I'm doing the 10 years first, and then times my N, or 12. All right, and then just put that in your calculator and see what we get. So be really careful when you put this in your calculator. I'm gonna show you guys how I want you to do that. So you put in 14,000 parentheses 1 plus. Now if you have the ability to do alpha y equals and go numerator denominator, so if you have that ability to do that, I want you to put that in 0.06 over 12 and then close the parentheses and raise it to the 10 times 12, 10 times 12. Some of you do not have the ability to do that, so I'm gonna show you what I would want you to do if you don't have that alpha y equals situation. I want you to do 1 plus and then in parentheses, your 0.06 divided by 12, close the parentheses. These two parentheses just show the fraction, and then close the whole thing, and then all raised to the, and you might even have to do 10 times 12 in parentheses as well. Just make sure you get the same answer, this 25,471 number, okay? And since it's money, we're gonna raise to the nearest penny. We're gonna round to the nearest penny, just kidding. So 55 would be what we round to. So $25,471.55. Okay? And that should make sense. That's kind of a lot, but it's after 10 years and it's compounded monthly, which is really good. Every month they reassess the amount of money Maria made on interest and they take the percent, 6% off of her $14,000 investment plus the interest she made. So she's earning more off of more, basically. It's kind of hard to explain, but hopefully you're following. Okay, after 20 years, I'm just gonna draw a line here. So I'm just gonna, I'm not gonna rewrite the equation. I'm just gonna go T equals 14,000. 1 plus, your rate is the same. Your monthly is the same, so over 12 times, I'm now doing 20 years times 12. Okay? And now I'm putting that in my calculator. Here's a little trick. You can either go up to the one, I'm gonna go up to the one I want and hit enter, and it copies it so that you don't have to go write it again. And then look at, I'm just gonna hit a 2 instead of the 10, enter. Holy moly, 46,000, that is a lot of money. Again, you want your interest compounded. The more it's compounded, the better off you will be. And we're rounding to the nearest penny, so 86 cents. And that's after 20 years. It almost doubled from 10 years. Wow, that's a lot of money. All right, moving right along. Question 2, I'm going to do this question with you, and then I think you guys will be good to do the follow-up questions on the back. This question has a little trick to it, so I just want you guys to follow with me so you can see what's happening here. So Theo invested $6,500 at 4.5% compounded quarterly. All right, so I see the word compounded, which means I'm using this formula. So I'm going to go ahead and write it down. T equals P parentheses 1 plus your R over N times your T raised to the T times N. I did it again. Okay, and we want to know what our P is, our R, our T, and our N. So if he invested $6,500, that's going to be our P. At 4.5%, that's going to be our rate. Written as a decimal would be 0.045. Again, you take your amount, move the decimal twice, 0.045. Compounded quarterly. So that means N, there's 4 quarters in a year, N's going to equal 4. What will his investment be worth after 4 years? I'm going to show you guys, so T is going to be 4, but I'm going to show you guys how to write the equation without knowing the time, and then we'll plug in the time after. When you want to write a generic equation for, like if you want to write this equation that would give you the amount compounded after any amount of years, you would put X in for T. And then you'd plug in the number for X, okay? So let me show you what that looks like. So T equals 6,500 parentheses 1 plus the rate of 0.045 all over N, which is 4, raised to the, I'm going to make TX just because this is going to be for the X amount of years, any amount of years. So N is 4, that's going to go here. It would be 4X. And then if I asked you, okay, after 4 years, how much would it be worth? You'd plug in 4 for X. If I asked you after 7 years, you'd plug in 7 for X, okay? So this equation would represent after any amount of years. If I want to know specifically 4 years, which I do, I would plug in 4. So 6,500, 1 plus 0.045 over 4, raised to the 4 times 4. And then T equals, let's plug that into our calculator. And if you want to do this math and just raise it to the 16th, that's totally fine. 6500, 1 plus, I'm going to do my alpha y equals 0.045. Be careful that you're plugging everything in correctly. That can be the biggest mistake. All raised to the 4 times 4, I'm just going to make that 16. If you don't want to do that, you can do 4 times 4. Enter. So the amount made is $7,774 and it looks like 10 cents when rounded. So $774.10. After you round, make sure you have the dollar symbol there. That's your answer. Now here's the part that they threw at you that you just have to make sure you're reading really carefully. How much interest did he earn? So he didn't earn $7,774. That's not how much money he made, because remember, he originally put in $6,500. So to find out how much interest he earned, we have to take the amount he has now and subtract it with what he originally put in, and that will give us the amount of interest. So I'm going to answer that question here. So we have to take $7,774.10 and subtract $6,500 from it. So I'm just going to take that minus $6,500. He earned $1,274.10 interest. So $1,274.10 he earned in interest. Okay, that was a 2-part question, so make sure you answered both of those parts. Okay, your follow-up questions are on the back. Again, this is in the template that I provided on documents and widths. And if you don't have a printer, you are more than welcome to write all this down. And I'm going to show it to you little by little so you can hit pause. But there are two questions, 2.5 I should say, for the 29th. Make sure you're correcting these on Friday. I just had a look at some of your assignments that you turned in, and a lot of you were not correcting your work. We need to see that you've done it, and then that you've gone back, and either if it was right, you star it. If it was wrong, I want to see your corrections, okay? Some of your work is beautiful. Some of you guys are skipping that part, and we are going to take off points starting next week if you don't show your corrections. It's a big part of this assignment, okay? So first thing you're going to do is review. This is review from last week. Graph the following function. It's 2 to the x plus 3. Make sure when you go ahead and put that in your calculator, you do 2 caret x, so that you're raising it to the x power, and make sure, this is huge, that you tab out before you do the plus 3. If you don't tab out, you're going to do plus 3 with the exponent, and that's actually going to move it left 3 instead of where this moves it, which is up 3. Okay? So go ahead and graph that. Remember that you need to use you need to graph a couple decimals here. So it should look like this is going to be a growth because the number is greater than 1. So it should look like in this direction that I'm making here. Okay, question 2 is more of what we went over today. So if you're writing this down, hit pause so that you can get all this down. It says Miss May deposits $2,000 into her account. Her deposit earns 5% interest compounded quarterly for 4 years. How much would the deposit be worth? So that's after 4 years, okay? And then here's the challenge. I want you guys to think about this one. And I want you to do your best and correct it on Friday. How much would her $2,000 deposit, so the same situation here, be worth under these same circumstances? Instead of after 4 years, though, it's going to be after 6 months. Notice the difference. This said years, this said months. So the hint is you have to think about how many years is 6 months. All right, so this one's a bit of a challenge, but I know you guys can do it. All right, and we'll correct this on Friday. Thanks for coming back again, and I'll see you guys soon.